Good morning, afternoon, or evening. Okay, we're going to be looking at the outline for the last unit, the graphing of polynomial graphs and sign-shaped graphs. Um, Equationally, basically, the only thing you've got to remember is the line equation form and the quadratic equation form and the cubic equation form of the polynomial graphs, which is from the first part. And maybe a little bit of the shape of the sine graph and the cos graph. Okay, because there's no real formula type stuff for this type of one. Let's get our preview open here, and then let's go through what's going to be on the quiz this morning. Okay, so firstly, this is our last unit in Math Foundations. And also, okay, we'll get that down to there. So we're looking at the outline for the polynomial slash sinusoidal graphs unit. 4. Okay, so let's go through each of the things that you can expect on the quiz. It's an 8-question quiz. You will need the access to Desmos, to be able to do this, or a graphing calculator, but Desmos works way better because you will have to do a quadratic regression graph, and that you need a linear one you could do by hand. A quadratic one you can kind of do by hand as well, except finding the equation of quadratic regression would be very difficult to do unless you knew some pre-calculus, which I'm not assuming everybody does. So what we'll do then is we use the quadratic regression on Desmos to help us out with that. Even if you plotted the quadratic equation by hand and then use Desmos to find the equation, that would be fine as well, as long as you have something to help you out with that one. Everything else is pretty much straightforward, so let's go through what we can expect on there. Okay, so the first thing is it's an 8-question quiz. I guess in terms of formula, there is a little bit on when we do radians and degrees, right? Okay, so I will provide a slight formula sheet to remember that pi radians equals 180 degrees, and also a couple other simpler ones, the regression formulas and that kind of stuff. But other than that, it's pretty straightforward. Okay, so the first type of question that we see, question number 1. Okay, my expectation in here is I'm going to ask you to determine or explain the shape and characteristics of the 4 kinds of polynomial curves we studied. Okay, so that's worth 4 points. Okay, so if you remember, we had the constant term, constant graph, I guess. And that basic form of that was y equals some number a. Okay, and the shape of it was flat. Then we had the linear graph. And that was first degree y equals mx plus b. And that one was a slanted line depending on whether you had a negative or positive leading coefficient going up a hill or down a hill. Then we had the quadratic graph. And that one was y equals ax squared plus bx plus c. And that one again, that's degree number 2. And again, you could have it opening up or down. Okay. Get that fixed. And the last one we looked at was cubic. Okay, now cubic graph is y equals ax cubed plus bx squared plus cx plus d. Okay, and this one here had kind of curled up and down or down and up. Okay, so it had two, as many as 3x intercepts and also 2 turning points in it are possible at a max. Okay, so that you can look back for in your notes for some of the characteristics of those. Whoops, not that one. Some of the characteristics of those if you want, but those are the basic 4 graphs that we're looking at, and we use these 3 when we did linear line regressions. We did linear regression, we did quadratic regression, and we did some cubic regression as well. Again, for the last 2 here, because we don't have all the pre-calculus there, possibly, we used Desmos to help us out in terms of finding the curve equation. Okay, so let's take a look at question number 2 then. Okay, now when we get into question number 2, I'm going to draw 2 different kinds of polynomial graphs. Okay, so you're going to be given a sketch. Of 2 different kinds of polynomials graph. And what you're going to have to do there is you're going to have to tell me what category of graph is it, and find the x and y intercepts on the graph, whether the leading coefficient is positive or negative. Okay, kind of thing. Okay, and you describe category of graph. The intercepts on the graph. And the sign of the leading coefficient. Actually, that one's not in there. That's the next question. Sorry. Okay, so something like this. If I had a graph that looked like this, Okay, and I had it kind of labeled out like that. You could say that this is a quadratic graph, x-intercept at plus and negative 6, y-intercept at 8, okay, and it's leading coefficient, it's a negative leading coefficient. Okay, and something like that. Okay, so something like that. You'll get two of them. There's quadratics, cubics, constants, and linear. So there's 4 possible ones. I'm not going to do all 4, but get 4 of them. Okay, then in question number 3 is a linear scatter plot. Well, that's worth 4 points. This one here. And then a linear, question 3. It's given a table. You create a linear scatter plot and find the line okay, and answer some questions. Okay. It can be hand. It says use graph paper on the sheet, but you can use Desmos if you want. Okay, so you can use Desmos. It says use graph paper, but if you use Desmos, you can just print out your graph that you make, do a screen print or whatever you need to do. Okay, that's worth 5. So that's a linear one. So that's going to be using y equals mx plus b. Remember with Desmos, if you're going to use Desmos, remember with Desmos, you have to put it in so that it says y1 is approximately equal to mx1 plus b, like this. Okay, where these are subscripts you have to have. Okay. See if they got subscripts in here. Yeah, they do. Okay, like that. Okay. So when you're putting in to find the line of linear regression, okay, so don't forget that. The questions that I'll ask is I'll ask you to interpolate and extrapolate some data. I might ask you what's the trend in the graph, that kind of stuff. Okay. Okay, question number 4, and that's worth 5 points. Question number 4 is some sine graph equations. You're going to be given, I guess is a bad word there, given some sine graph equations okay, describe the period amplitude and shifts on the graph. As compared to the original sine graph. Okay, so something like this. So you might have, and that's worth 4 points. There's 2 of them. Okay, so you might have something like, let's say, 4 sine 2 bracket x minus 20 degrees plus 1, y equals. Okay, so we know that A equals 4, B equals 2, C equals 20, and D equals 1. So therefore we can say that their amplitude is 4. Pi. Okay, we can say that the graph just shifted up 1. Okay, we can say that the graph is shifted okay, so it's inside the bracket, it's going to be opposite way, 20 degrees forward or to the right. Okay, and the last one we can say is that the period is going to be 360 divided by B, or 180 degrees. Okay, both of them are in degrees. I didn't use radians for that. Okay, so something like that. That would be number 4, and that's worth 4 points. Okay, number 5. Let's flip the page here. Okay, so question number 5 is converting degrees into radians. 2 points, 2 of them. So converting degrees into radians. Okay, and that's only 2 points. There's 2 of them, but they're simple. Okay, so an example of that would be convert to radians. Say 76 degrees to radians to 3 decimal places. Okay, so we know that if we're going to do this, we know that pi radians equals 180 degrees. That's our knowledge, and then we are asked to find radians, so we put an x there, and we're given degrees, so we put them down here. Then we simply do a cross multiplication here. So 76 degrees times pi is equal to 180 degrees times x. Okay, so then we can take and go 76 degrees times pi divided by 180 degrees. It's going to give us x. Degrees will cancel out, we're left with radians. So if we go on our calculator, go 76 times pi. Okay, I have a pi button on my calculator, so it looks like that. Okay, and then I divide by 180. Okay, I get 19 over 45 pi's, or to 3 decimal places, 1.326 6. Okay, something like that. Okay, the next one, number 6, is the opposite of that, converting radians into degrees. So question number 6. Again, that's 2 points. There's only 2 of them. And this time I'm going to say go to the nearest degree. So an example of that, convert 4.45 radians into the nearest degree. Okay, so if we're looking at that one and we're trying to figure that out, we can use the same technique except switch the place where we put the x. So we can say to ourselves, okay, well, that pi radians over 180 degrees. Okay, this time I've got the radians. And I need the degrees. So I got pi x equals 4.45 times 180. Okay, so divide both sides by pi. So x equals 4.45 times 180 over pi. Okay, so what does our x give us in this case? Get our calculator out. 4.45 times 180. That gives us 801 divided by pi. And I get 254.96 or 255 degrees. Okay, notice I did not have any arc length formula or anything like that. I just stuck with the basics for that one. Okay, so the basics of converting back and forth into degrees there. Maybe I should move that up in case I'm in the way. Okay, so that's 6. There's 2 other questions left. 1 or 7, pardon me, not 1. On here, so let's do that on the next page. So number 7 is a sinusoidal curve, and that is shown, and you have to find the equation of the midline, the amplitude, and the period of the function. So that's number 7. So you're given a drawn find the equation, the midline, period, and amplitude of the graph. Okay, for that. Okay, so I don't know. I had something like this. It's kind of hard to do with freehand here. Oops. So if I had a graph like this, and let's say it went like that, and we knew that this was 2, and this was -2, and this was 10, 20, 30, 40, 50, 60. Okay, so the equation of the midline is y is going to equal 0 because that's the midline. Okay, so you might have to calculate it. Remember that the midline is max plus min divided by 2. So that would have been 2 plus negative 2, which would be 0 divided by 2. I guess we should write it out. Okay, you can look on here, but if you can't find it, you just take the max and the min. Right? Okay, and the amplitude equals 2. And if you can't remember how to do that one, that's max minus the min divided by 2. Okay, so that would have been 2 minus negative 2 over 2, which would have been 4 over 2, which would equal 2. So the amplitude was 2. Okay, and the last one is the period, how long it takes to repeat itself. So period is 20 in this case. It's got to go once, twice, 3 times. Okay, something like that, or similar to that. And the last one is a quadratic regression chart to graph. So question number 8. Oop, there it is. Put it over here. Doesn't really matter if you see it or not, you still have to graph it. So you saw there, the last one will be 6 points. Number 8. It's a quadratic regression graph. Okay. And so you have to create the scatter plot, SMOS would help here. Okay. Then do some extrapolation or interpolation with the data. Okay, and you also have to find the equation. Okay, so that would mean a 6-pointer. And that's our graph. That's our equation, our exam. Okay, couple of graphs, one linear, one quadratic. Okay, some converting from degrees and radians back and forth, some polynomial curves, naming them and identifying them, some sine curves, finding the amplitudes and the periods and the shifts in them. Okay, and that's basically the whole equation, the whole exam. Okay, so we will stop there. I will send this stuff off to your supervising teachers for when you're ready to write it. Okay, so then a couple of things. Oops. Got to printing the other one out here. There we go. Sorry about that. It's printing away there. So what we are going to be looking for in the next little while then is, if we're done, it's beginning of June here or so, we're going to be looking at preparing for the final exam. So what I have here, I've created, can't quite see it from here, but if you look way over on the whiteboard over there, I have answers posted in sheets. So I have, for my kids here in Vanguard, we started already. There are 4 sections, review sections with answers to work on and study with. So in the last week or so, before you're going to write the final exam or whatever, you can look online. I'll post those online under the final exam review, and they'll have the questions will be there, and then underneath will be the solutions, and you can use those to study. Now I've got, actually, to be truthful here, I guess there's only 3. I haven't made one for the graphing unit yet. I've only made the first 3: the financial unit, the set theory unit, and the probability unit. Okay, so that'll be there. Okay, the other thing to remember, and this is extremely important, you are allowed to make your own formula sheet and bring it in on an 8.5 by 11 piece of paper. Make sure that you make that. You can write anything on that paper you'd like, okay, to help yourselves out while you're working through math. A reference sheet. That's part of your studying in my eyes. If you have to take the time to prepare that. If you don't take the time to prepare that, you won't have a formula sheet. It makes it really difficult. So I like giving that option to students because you have to do some studying when you're making a formula sheet up, and you have to know what everything means and where it comes from. So it does make the exam easier as well if you do a lot of prep work and build up that sheet, which is an advantage for you guys. So don't miss that chance. Okay, so don't forget that is allowed in my exams. Call them a cheat sheet or a formula sheet, whatever. You have to make that up. Okay, I'll put that in my final exam part when I send it out later on in June here. Okay, so that's it for all of the content that we're going to do. And in the next week or so, first week of June, I guess in this case, we are going to do some of that review. It might take us about 7-8 days to do it because there are four review sheets with about 7 to 10 questions on each. So with solutions, and you can work through them and help you out. So I'm going to stop the video there and post this, and hopefully everything went good in the last unit here.